Hi, my name is Lihini Ranaweera. I'm in 8th grade, and for my scenario project, I decided to study astronomy and astrophysics. Astronomy is the study of the sun, moon, stars, and other celestial bodies, while astrophysics studies the physics and the properties of these objects. Cosmology, which is something that I also was interested in, is the science of the origin of the universe. Astronomy has two main branches, theoretical and observational. Theoretical astronomy models and analyzes how solar systems might have evolved, while observational focuses on what we can directly see via radio waves, infrared technologies, and other devices. These two types blend together because we can't really see the life and death of an entire system as a whole, so we combined what we think might have happened with what we know happened. I also studied stellar astronomy, which is a subtype that focuses on stars. As you might know, there's several types, including white dwarfs and blue supergiants, which is what you can see on the left. Stars are classified in an alphabetical system based on their temperature and spectra, or the types of elements that stars absorb. I also studied astrophysics, and I focused on three main topics: galaxies and galaxy clusters, general relativity and gravitational radiation, and the interstellar medium. Well, how do galaxies form? Clouds of gas would collect into a protogalactic cloud, also known as a cloud in the process of forming a galaxy. Within these clouds, stars would start to form, and over thousands and thousands of years, gravity would continually collapse them until they formed a rotating disk. Now, galaxies can come in several shapes, but two of the most common types are elliptical and spiral. And the rotating disk that I talked about would become either an elliptical or spiral galaxy based on their angular momentum or how fast they're spinning and its cooling process. Galaxy clusters also exist in our universe. Rich clusters have over 1,000 galaxies, and poor clusters have less than 1,000 galaxies. The Virgo supercluster has roughly 2,000 galaxies, making it a rich cluster, while our local group only has about 30. I also study general relativity. General relativity is a theory of space and time that morphs the two together in something called spacetime. This theory was generally discovered by Einstein. Spacetime is curved when there's energy, matter, and momentum. As you can see, the flat plane is what we would call spacetime. As the two balls have matter and momentum, spacetime curves around it, creating a force that we know as gravity. Gravity can be modeled using the Einstein field equation, which uses tensors, or mathematical objects, to describe the curvature of spacetime and how it creates gravity. It includes things like the Ricci curvature tensor, the scalar constant, cosmological constants, and the Strassen energy tensor. Lastly, I studied the interstellar medium, which is the space between stars. It plays a role in the chemical evolution of galaxies because it has a fair amount of gas. Lastly, I studied cosmology. This theorizes about the origin, ultimate fate, and structure of our universe. The most popular cosmology theory is the Big Bang, which I'm sure you've heard of. With this theory, it states that the universe started with one singularity, but this singularity was incredibly powerful and created the universe that we know today that's still expanding. How do we know it's real? Well, when the universe was a couple seconds old, it was incredibly hot, roughly a billion degrees Kelvin. This heat created leftover radiation that we call the cosmic microwave background. In relatively recent years, we've discovered remnants of the cosmic microwave background, which is how we know that the Big Bang occurred. Throughout the year, I decided that I was going to observe constellations and try and get myself as comfortable as possible with identifying stars. I used apps, computer programs, and websites to aid my learning, and I can confidently say that I can identify quite a few constellations just by looking up. Lastly, I hosted a viewing party. I was planning on hosting an in-person viewing party, but seeing as current events didn't really let me do that, I put it on Teams instead. I hosted a Microsoft call that had about 19 people in it, and we got to observe the meteor shower and really have a good educational time. I hope you enjoyed this, and I hope you learned something.